Hello students, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the course Mathematics 1 and our chapter is partial derivatives and today's topic is chain rule. Okay, so today we are learning about chain rule. For that we need only basic requirement, formula of differentiation and rule of differentiation. And as we studied in previous lecture, first order partial derivative and second order partial derivative. So only we need partial differentiation. That means how do we differentiate when we one with respect to one variable, at that time other variables treated as a constant. So let's start with the very first point, differentiation of function of function. So what is differentiation of function of function? So let's understand with this topic. If w is a function of r, that means w is equal to f of r, and r is a function of x and y, then del w by del x is equal to dw by del dr into del r by del x, and del w by del y is given by dw by dr into dr by dy, del r by del y. This is our chain rule. Okay, but how we applied this? So for that, just look at here how. So we have w is a function of r, and we know that r is a function of x and y which is given. So w is equal to f of g of x comma y. That means ultimately what happened, that w is a function of x and y. So we can differentiate, and we have to differentiate this w with respect to x as well as y, one by one. So this becomes like this chain. W contains r and r contains x for x and y. So if we want to differentiate w with respect to x, we cannot differentiate directly. So we have to go through r. So del r by del x, so del w by del r, del w by del r. So you can use del or d also. Why d? I am just using d here because w contains only one r. So total derivative, and r contains x and y. So del r by del x, which is partial derivative. Okay. Same way, if we want to differentiate w with respect to y partially, so we go through r, dr by dw by dr and del r by del y. Okay, so this is our formula for function of function. Got it? Now same way, if w is a function of r and r is a function of x, y, z, three variable. So same process happened, but here w is a function of r and r contains x, y and z. So we can differentiate w with respect to r, x, y and z, three. So first del w by del x, that means dw by dr and del r by del x. Same way del w by del y is equal to dw by dr and del r by del y. Same way del w by del z is equal to dr by del z. Okay, now you can also del here, but here w contains r only, it is clear shown, so I am using d, that means total derivative. Okay, so this is called function of function. Why function of function? It is clear seen, w contains r, w is a function of r and r is a function of another three variables or two variables. That means function of function. So let's understand this topic, this point with examples. So first example we have, if v is equal to 1 by r, that means v is a function of r, we can write like this, v is a function of r, and where r square is equal to given by x square plus y square plus z square, that means r is a function of x, y and z. Okay, so this become function of function. Then show that v of x comma y comma z, this is z, v of x comma y comma z satisfy Laplace equation. And what is Laplace equation? So this is our Laplace equation. Okay, so whenever Laplace equation, you have to ask to satisfy Laplace equation, so you have to remember this equation. Rather it is given question or not, but you have to remember this equation. That means 2 time with respect to x, 2 time with respect to y, 2 time with respect to z. If only two variable is given, x and y, so no need to add this. Okay, that means 2 time with respect to each variable and its addition gives answer 0, which is our Laplace equation. So let's start with the solution. So let's first of all write down v is equal to 1 by r and r square is equal to x square plus y square plus z square, which is given in the question. So first we will find this. First I am just removing all this line. First we will find del square v by del x square. For that first we will find del v by del x. So del v by del x is given by del v by del r and del r by del x. Chain rule. Okay, this is chain rule. Now to find del v by del r we will use this. That means v, differentiation of v with respect to r, which is given by, we know that 1 by r, differentiation of 1 by r is minus 1 by r square, and del r by del x, that means differentiation of r with respect to x, which is obtained from this r. So let's have a look. If we want to differentiate this r with respect to x, then first we differentiate r square. So differentiation of r square is 2r and differentiation of r is del r by del x is equal to differentiation of x square is 2x and differentiation of y square and z square will be 0, because we are differentiating with respect to x partially. At that time y and z are treated as a constant. By cancelling 2, we have del r by del x is equal to x by r. Okay, so value of del r by del x is x by r and value of del v by del r is minus 1 by r square. Just write down by simplifying minus x by r cube. This is our del v by del x. Now again we differentiate this term with respect to x. So x in numerator and in denominator also, because r contain x, y, z. So r contain x. So we will use here division rule. Okay. So we have del square r by del x square is given by quotient rule only. In denominator square. Okay, from last 2-3 lectures we are using this formula, so we are familiar with division rule. Denominator as it is, differentiation of x is 1 minus x as it is, differentiation of r cube is 3r square and differentiation of r is del r by del x, because r is a function of x, y, z. Now we will put the value of del r by del x, which is obtained here, x by r, and by cancelling out this r, we have, by simplifying, minus as it is in bracket r cube minus 3x square r by r raised to 6. Similarly, you can find del square v by del y square and only change with this x. X will be y. So final x square will be y square only. Other than this change in variable x and y, there is no change in process, so we can directly write down similarly. Okay, we can. So now we have one more example. They have a look at this example. This is our example. Next, if u is equal to f of r and r square is equal to x square plus y square, then prove that del square u by del x square plus del square u by del y square is equal to f double dash of r plus 1 by r into f dash of r. Okay, same process as previous example. So let's start with the solution. Before that, I am just writing down here this chain u contain r because u is a function of r and r is a function of x and y. Here two variable is given. So when we differentiate u with respect to x, we will make this chain. Okay, and same way for y, we will make this chain. Okay, so let's start with the solution. Del u by del r. Okay, del u by del r is del u by del u by del x, and del u by del x is equal to del u by del r into del r by del x. So what is the value of del u by del r? We know that differentiation of u with respect to r, which is f dash r, and del r by del x is x by r, as we have seen in previous example. That means differentiation of r square is 2r, and into del r by del x is equal to 2x. 2 cancel out, and we will get del r by del x is equal to x by r. We will put here. Now again differentiating with respect to x, at that time we will use product rule in between these two functions, this and this, because this f dash r itself contain x and this also function also contain x. So by product rule, first as it is, differentiation of x by r is, how we can find differentiation of x by r? By using quotient rule. That means because numerator and denominator both contain x. Okay, that's why we will use division rule. And how we apply division rule here? Let's have a look. In denominator square. In numerator, this r as it is, differentiation of x is 1 minus x as it is, and differentiation of r is del r by del x. Same way, the second term as it is, and differentiation of f dash r is f double dash of r, and we know that by chain rule, differentiation of r is del r by del x. Now we will put the value of del r by del x here and here. What is the value of del r by del x? Yes, x by r. So we have this x by r, so x into x square by r. Same way here x by r, and this is x by r, so it will be x square by r square, f double dash r as it is, f dash r as it is. Now by taking LCM here, so r square minus x square, and r goes with the denominator, so we have r cube. So we have this, and this is our equation number 1. Same way, we will find del square u by del y square, and change will happen only here and here. Rather, all the processes are same, so we can write down similarly. No need to find del square u by del y square again by full process. We can write directly similarly. Now in left hand side we will put the value of this both. So this is the value of del square u by del x square, and this is the value of del square u by del y square. So in first term, and from this first term you can take f dash r common, this. So by adding this two term, this plus this, and from this second, this term and this term, we can take f double dash of r common, and by adding these two terms, we have x square y square upon r square. Now we know the value of x square y square is r square, already given in the question. And by simplifying this, we have r cube is our LCM, so we can take LCM. So by adding numerator, r square plus r square, 2r square, and if we take minus common, so we have x square plus y square. And we know the value of x square plus y square is r square. This r square cancels out. So we have 2r square minus r square. And 2r square minus r square is r square. So r square, and in denominator r cube. So we know that by cancel out this, we will get 1 by r. So we have final answer, and which is our right hand side. Okay, so same process as we have seen in previous lecture, that means second and higher order partial derivative, but starting 2-3 steps only change. Okay, that means we are using chain rule over there. Okay, so one more example we have, and we will understand again same chain rule. Okay, so we have this: if u is equal to r raised to n, and r is given by under root x square plus y square plus z square, then show that 2 times with respect to x, 2 times with respect to y, and 2 times with respect to z. Addition of these three gives answer this. Okay, same process. So let's start with the, here you can also see that u is a function of r and r is a function of three variable x, y, and z. So whenever we differentiate u with respect to x, we will make chain same way for y and same way for z. So let's start with the solution. First write down u and r. So del u by del x is equal to del u by del r and del r by del x, and del u by del r is given from this. So differentiation of u with respect to r gives r raised to m, that means m forward, and r raised to m minus 1 and del r by del x. Now how we can find the value of del r by del x? Same process as previous, but here r is given in the form of this. So we can take square on both sides, so we get same process as previous examples. Okay, now we know that how to find the del r by del x from this. Okay, and value is same, x by r. So we'll put x by r. Now by taking this 2r together, we have m x and r raised to m minus 2. This is our del u by del x. Now again we differentiate this with respect to x, that means second order partial derivative with respect to x. Just m is constant, so we can take outside of the bracket as it is, and we will apply product rule on this two term. So in product rule, we know that x as it is, differentiation of r raised to m minus 2 is m minus 2 into r raised to m minus 3 into del r by del x, because r is a function of x by z, plus r raised to m minus 2 as it is, and differentiation of x is 1. Now we will put the value of del r by del x, and we know that the value of del r by del x is x by r. Now by simplifying this term, r and this r will take together, so r raised to m minus 4, and this x and x becomes x square, and if we multiply m in this bracket, so m multiply with this term and m multiply with this term, so we have this one. This is our equation number 1. Similarly, we can find del square u by del y square and del square u by del z square. Okay, only change will happen to this y square and z square. Okay, then we will put the value, all this equation 1, 2 and 3 in left hand side. So we have this 3 term, 1, 2 and this 3. Okay, now we have this 3 term same. So this 3 time, and from this 1, 2 and 3 we can take common. Which term we can take common? M into m minus 2 into r raised to m minus 4. So m into m minus 2 into r raised to m minus 4 common, and we have x square plus y square plus z square in one bracket, and this becomes 3 times. Okay, as we have discussed. And we know the value of x square plus y square plus z square is, yes, r square. So this is our r square. So now again making this base same, addition of power gives r raised to m minus 4 plus 2. That means m minus 2. Now we can take common m and r raised to m minus 2. From this 2 term we will get this common. In bracket we have remaining part m minus 2 plus 3. So m minus 2 plus 3 is m plus 1, which is our right hand side. So these are the example of basic chain rule, that means function of a function. Now we will understand chain rule, but for different kind of function, that means total differentiation of composite function of one variable. Now what is composite function of one variable and how we can find total differentiation? So let's have a look on that. So first it is given that w is a function of x and y, and x is a function of t and y is a function of t. That means we have w is a function of x comma y. If we put the value of x, that means w is f of g of t. If we put the value of y, which is h of t, ultimately we can see that w is a function of t. Okay, then w is a function of t. So how w becomes function of t? Like this. And it's called composite function. So which kind of function called composite function? Here you have seen of single variable t. Then total derivative, that means this total differentiation of w, that means this w with respect to t, with respect to this t, is given by this. And this is our formula. For example, dw by dt is equal to del w by del x into dx by dt plus del w by del y into dy by dt. How this formula is generated? Let's have a look on this chart. Here given that w is a function of x and y. Okay, so w is a function of x and y, and x is a function of t as well as y is also a function of t. And if we want to differentiate w with respect to t, we cannot go directly because in between we have chain of x and y. So if we take first, we'll take the chain of x. So del w by del x, del w by del x and dx by dt. Why here del and here d we used? Because w contained more than one independent variable, two independent variable, and we have seen previously if any function contain more than one independent variable, then we have to use del because it gives partial derivative, and this x contain only one variable t. So here we are using d, that means total derivative. Okay, that means total differentiation, or we can say ordinary derivative. Now after using this part x, now we have y also there, which also contain variable t. So del w by del y and dy by dt, which is given here. So this is our formula for example. Okay, same way, if it is given that w is a function of three variable x, y, z, and all three variable contain t, that means like this: w is a function of x, y, and z, and all these three x, y, z contained variable t. So total differentiation of w with respect to t is given by this. That means we have to just add this third term z. Other than that, there is no any change in formula. Okay, so we have this two formula which we will use in example. Okay, so take a look. Okay, take a look on this example, and we will use these two formula. Take a look on this formula. We will use these two formula in next coming examples. So in each and every example, if you don't understand, you can make this kind of chart, so you will understand better. Okay, so let's start with the first example of composite function, and in question it is given by using chain rule, evaluate dw by dt. From here you can understand which kind of example it is. It is clearly shown that w is a function of x square plus y square plus z square, that means x, y, z. So w is a function of, we will make chain x, y, z, and x is a function of t, y is a function of t, and z is a function of t. Then we have this chain. Okay, so you can make this kind of chart, and if this kind of chart is created, then we will use that same formula. After finding dw by dt, we will find the value of dw by dt at point t is equal to 2. So let's start with the solution. First we write down w and the value of x, y, and z. Now, by total differentiation and chain rule, we have the formula dw by dt is equal to del w by del x into dx by dt plus del w by del y into dy by dt plus del w by del z into dz by dt. Now we will find these three values del w by del x, del w by del y, del w by del z from this function, and this dx by dt from this x, dy by dt from this y, dz by dt from this z. So first we will find all these six derivatives and we will put in this equation 1 and we will get the answer. So what is the derivative of w with respect to x? 2x, because we know that in partial derivative, when we differentiate with respect to one variable, other variables treated as a constant, and we know the derivative of constant. Okay, same way with respect to y and with respect to z. Now to find dx by dt, we will use this, and when if we want to differentiate with respect to t, so we have to use product rule here. So we have first t as it is, differentiation of cos t is minus sin t, plus cos t as it is, and differentiation of t is 1 by simplifying minus t into sin t plus cos t. Same way dy by dt, and same way dz by dt. Dz by dt differentiation of t is only 1. Now we will put all these six values in equation number 1, and we know the what is the equation number 1, which is already given. Okay, so this is our equation number 1. So we will put the value of this is 2x, the value of dx by dt is this, del w by del y is 2y, dy by dt is this, del w by del z is 2z, and dz by dt is 1. Okay, now we have to convert this x, y, z into term of t. Then we can put the value of t is equal to 2. So what is the value of x, y, z which is given in the question? So value of x is t cos t, is bracket as it is, value of y is t sin t, value bracket as it is, and value of z is t only. One no need, because multiplying with 2z is itself. Now we will multiply 2t cos t with this bracket with this bracket, and 2t as it is. So we will get this whole entire term, and we can cancel out this. You can see this 2t square cos t and 2t square sin t cos t cancel out. So we have remaining this term and this term. We can take 2t common, so we have cos square t plus sin square t, which gives 1. So 2t plus 2t is 4t, and which is our answer dw by dt. And by putting at t is equal to 2, we have dw by dt at point t is equal to 2 gives 2 to the 2 here, so 4 to the 8, which is our final answer. Okay, so this is the example of total differentiation of composite function in single variable. Okay, one more example, same example like, but with two variable. That means u is a function of two variable. That means we have this kind of chart. U contains x and y, and x is a function of t, y is a function of t. So we have same kind of chart, and if we want to differentiate u with respect to t, we will use total differentiation and chain rule, du by dt. Okay, so let's start with the solution. First write down u and x, y. Okay, now by total differentiation chain rule, formula is du by dt, it is equal to del u by del x into dx by dt, del u by del y into dy by dt. We will find all these four derivatives, finding del u by del x and del u by del y from this equation. So we have partial derivative with respect to x and y, which is already we have learned, and du by dx from this. So we have cos t, and dy by dt is this from this. Put all these four value in equation number 1, So we have this equation number 1 and we are putting this. Now instead of x and y, we will put the value of x and y which is given in the question. X is sin t, y is cos t, x is sin t sin square t, y is cos t. Now by simplifying and taking common, so we have e raised to cos t and sin t common, so remaining 2 cos t, and here only sine square t. Okay, because this sine t will just taken common. Now at point t is equal to pi by 2, so we will put the value of t pi by 2, pi by 2, pi by 2, pi by 2. We know the value of cos pi by 2 is 0 and sin pi by 2 is 1, so we will put the value over here and here also. So e raised to 0 is 1, this is 1, 2 as it is, cos pi by 2 0, sin pi by 2 1. So by simplifying this, we have final answer minus 1. And similarly, we have these are the DIY, that means do it yourself. These are the practice example, and we know that by practice you can understand better, and this will help you to understand next lecture better. So keep practicing, okay? Keep learning, and we will see with next lecture. Thank you very much.